my name is Jason Gallenbricky, and I'm the Global Account Manager at SICK, responsible for General Motors. If you're not aware of SICK has been in business for over 75 years. As far as General Motors and on the GACL kind of contract, mainly our products that we sell into GM is around safety and some of the photo eyes, but we also do a lot of vision as well, and that's kind of what we're here today to introduce Ryan and talk more about the 3D vision and AI vision.
Yeah, thank you, Jason. So yeah, my name is Ryan Morris. I'm Market Product Manager here in the SICK in the US, specifically focusing in on our machine vision portfolio. So whether that be 3D machine vision cameras or into our 2D portfolio with our inspector line, really with the focus on, again, as you mentioned, the AI capabilities that SICK now offers on board of our 2D cameras.
Mm-hmm. So some of the areas that we see within the automotive industry, some of the problem areas as migrating more and more into robotic, for the use of the manufacturing of the vehicle, the need for quality inspection has really increased. So as you look into like the body assembly and whatnot, and even in the powertrain and EVs, vision can really, the 3D vision as well as the inspector here can really kind of help solve a lot of those problems.
Yeah, no, totally agree. As we start talking about different problem statements and applications that we have seen in the automotive industry, there's obviously a lot of pros and cons to what technology do I use, what is best suited for certain applications. 2D has probably been the more traditional sense as far as machine vision aspects to it. It's probably what more people are familiar with. However, with 3D devices, we do have a lot of advantages that we can achieve here now, especially when we start offering in some ease of use configuration software, making that barrier of entry to 3D vision a lot simpler, a lot easier to be able to solve applications more rapidly and utilize the benefit of 3D vision and triangulation specifically with our ruler and ranger cameras here. Looking at the two products here, you can see they obviously look much, very different. With our ruler camera, it's based off of our Ranger 3 solution. As we start looking at 3D triangulation, some of the benefits that we see to that, especially in the automotive space, is it's very fast. So very fast, very high resolution. So we're talking, capable to be able to scan wide field of views up to 1.5 meters wide or so. So again, big enough for a car.
Yeah, right. Yeah.
But then also be able to have that sub-millimeter resolution and accuracy. So as we start talking 3D vision, it's a little less susceptible to the ambient conditions. Mm-hmm. So lights on, lights off, low contrast scenarios. 3D vision really is powerful there because now I can see that nut or that bolt or that weld that has potentially very low contrast, but now I get some height information. I can get some defect analysis based off the 3D height data that I can get out of the ruler.
So actually, you brought up a really good point there. So as far as with the 3D vision, so do you need backlighting?
No. Yeah. So we how 3D vision works, or triangulation in general, is we have an internal laser source here. So you can see here, we got a nice little laser that would project down, and basically the camera is now looking at that laser line as its light source. So we're taking pulses and actually recording that laser profile at a very, very high rate of speed, up to 46,000 scans a second. So we're very, very fast. But as that internal laser source is generated, that is what the camera sees. So again, lighting doesn't need to happen. Mm-hmm. So very, very good in that sense, where you don't have the ambience affecting hotspots or glares or skylight overhead all of a sudden certain times of day is different. So
right. Yeah. So what about as far as, does the part have to be static or moving?
So with 3D, yes. So static in a sense where the product does need to move or the camera needs to move. So we do, as we're taking a field of view, we are actually scanning a field of view profile. So whether that be a camera on a robotic arm, looking at a stationary static part, or on a conveyance sense if a part is moving underneath, that is also perfectly fine. So there is motion required to create that 3D imagery. don't have a product here right now, but we do have static time of flight snapshot 3D devices, little lower resolution type of cameras with our Visionary Mini. Really more for maybe gross defect analysis, but for the higher res applications, we would require some sort of motion with that triangulation technology.
Okay, so then with 2D, do you have to use backlighting?
So 2D needs lighting.
Yeah.
So whether that's backlight, whether that's internal light, or getting into some specialty lighting, depending on what features you want to pull out, 2D would require some sort of lighting. With our inspector cameras, we do come with internal ring lights here, so we do have some internal illumination, so you don't have to bring in that extra lighting or extra backlighting. Okay. However, depending on the application, you might benefit from external lighting, but not a requirement in all sense of the applications.
So then, how do we work with like AI within the Inspector 830?
So especially around, AI is a big buzzword topic now. How does AI help me enable and solve applications? So really what it's enabling in my mind is ease of setup. Being able to solve applications quickly that maybe traditionally I would be able to solve with traditional machine vision tools. But now, so as far as looking at maybe in the assembly process, looking for defect analysis, or is there a chip or a scratch, or that would have been a very tough application in the past, where trying to use pixel counters or edge locators to find a scratch or a defect. Where now utilizing AI, we can train an AI network directly on the camera itself with just a collection of good images.
Okay.
So what we would actually do is, take a picture of that door, 1, 2, 10, up to 100 pictures of that door. We actually save that onto the camera itself. We trade the AI network for the anomaly detection, and then we just let it run. So ideally, anybody who is on the floor can probably tell you what a good part looks like, hopefully, or what part A or part B looks like. And they can just say, this is what a good part is, click, train, and you have a working algorithm. So really reducing the barrier of entry to machine vision in that sense too, being able to utilize that AI capability.
So what if you have like a gray area as far as like, this is kind of good or kind of bad, but it's not yet bad enough to where we have to flag it bad? Can it learn like that whole process?
So it is depends on what you input. So we train on good images only. So if you have variances of goods, you can train what those variances look like. We can also input bad images if we have known bads. Not required, but we just need the goods. Now it's not just a binary pass-fail. So I think that's what you're alluding to. So,
but that's good.
So what we actually do is we build up these AI networks for anomaly. We actually give you an anomaly score. So based off of the known reference set, we'll say, okay, we got an average score of 5 or 10 is my anomaly. And then we can set a threshold, say, okay, if I ever get an anomaly greater than 40, relative to the anomaly scale, I should say, from 0 to 100, and then we can flag it saying, hey, this is bad. So you do get that score, and you can output that score as far as what variances of good and bad are we actually seeing, because we do have a physical number tied to the anomaly itself.
Okay. Cool. Well, I kind of interrupted you there as you were going through your answer. Did you have anything more to talk about 3D or 2D vision?
Just in general, like, SICK has been around for quite a while. We might not be the first name you think about when you think vision. SICK, as you mentioned, is very strong in photoelectrics and safety. However, SICK has been in the machine vision industry for 20, 30 years, specifically with a big focus on 3D initially. And then the 2D cameras we've had, I think we came out with our first inspector portfolio back in the early 2000s. So we've been around for around 20 years with 2D cameras as well. But we're really starting to build up our software competencies and be able to make the cameras more accessible and ease of use to be able to solve these tougher applications. Whether it's looking at something with a 2D camera, utilizing the onboard AI here now, or accessing our higher end 3D devices with the Ruler product line.
Yeah, cool. Alrighty, well, thank you for joining us today. If you'd like more information on the products we talked about here, You can visit sic.com, email us at info@sic.com, or you can reach out to me directly in the contact information below.
Thank you.
Yeah, thank you.